everyone. So now we'll see what is average speed and what is average velocity. Okay. So the ratio of total distance by time taken is known as average speed. Okay. The ratio of total distance by time taken is known as speed. Okay. And what is velocity? The total displacement by time taken is known as average velocity. Okay. The ratio of total displacement by time taken is the average velocity. Okay. So to explain this, I'll take one example. Let us consider a train. Okay. Let us consider a train. This is one station called Khagas. Okay, according to textbook, it is Khagas. Now, the train is traveling from this initial point to somewhere around this. So, this is one intermediate station and it is traveling over here to Hyderabad. Okay, it's traveling to Hyderabad. Okay, this is the complete distance. So, this is my originating point, which is nothing but the initial point. And this is my final destination, which is the final position or final point. So this is the complete distance the train is covering. Okay. So let us consider the distance is around. So distance covered by the train is 300 kilometers. Okay. The distance covered by the train is 300 kilometers. And the time taken to cover this distance. Okay. The time taken to cover this entire distance, let us consider the time as 6 hours. Okay, let us consider the train took 6 hours to complete the distance from here to Hyderabad. Okay, from Khagas to Hyderabad. Now we have distance as well as time. So we can calculate the average speed. See, in this distance, I told you it is a scalar quantity. It does not have any direction. Okay, so it is traveling in any direction. Okay, the distance does not have any direction. Okay, does not have any direction. So for this, the total distance is 300 by the time taken is 6 hours. Time taken is 6 hours. If I cancel this, okay, I'll get it as 50. Okay, 50 kilometer per hour. Why kilometer per hour? This is in kilometer and this is in hour. So divided. Kilometer per hour. So I'm getting the answer. The average speed as 50 kilometer per hour. So now let us see what would be my displacement. Okay, what would be my displacement? So displacement is nothing but the shortest distance between the initial position and final position. So this is my initial position and this is my final position. So if I draw a straight line joining my initial position and final position, this would be my displacement. Okay, this would be my displacement. Let us assume my displacement as, okay, so let us assume my displacement as 120 kilometers. 120 kilometers. Displacement is 120 kilometers. And the time taken is same. Let us assume the time taken is same as 6 hours. The time is taken is same as 6 hours. So now we have a displacement, total displacement and time. So now, and it is traveling in a particular direction. Okay, it is traveling in a particular direction. Say this is a south direction. Okay, this is a south direction and south and is traveling towards the west. So let us consider the southwest direction. So as I told you that displacement has direction. So now let us calculate the average velocity. So for average velocity we have total displacement which has 120 kilometer Okay, total displacement as 120 and time taken is 6. So if we divide this, we'll get it as 20. So kilometer and hour. So kilometer per hour. So this is my answer, the average velocity. So velocity has direction and speed does not have any direction. Okay, speed does not have any direction. So I hope it is clear. So now let us do an activity number 3. Okay. So in this activity, we'll be measuring the average speed and average velocity. Okay. So we'll see how to measure the average speed and as well as how to measure the average velocity. So for this, we'll do one experiment. We'll do some simple experiment to find out the average velocity. Okay. To find out the average speed. Okay. Firstly, we are finding the average speed. So what we have to do is, let us ask few students. So let us consider these are the students to start, like S1, S2 and S3. Ask them to stand at one particular position. Let us consider at B. Okay, at A. Say all these students are standing at A position. And now similarly ask few students to stand at B. Okay, stand at B. So now the student standing in B, give them a stopwatch. Okay, stopwatch. Give them everybody a stopwatch to note down the time in which they are covering this distance. Okay, in which they are covering this distance. So give them the stopwatch and now ask the students to randomly run towards the respective students. Okay, which are at B. Okay, ask them to run towards the respective students with any speed or any direction. Oh, any direction. So they can move in this direction also, they can move like anyway, they can move in a zigzag way or they can move in any direction. Okay, so ask them to walk or run in any direction towards these students. Okay, and ask these students to note down the time. So let us consider the student 1 has travelled a distance, okay, this distance in just say 5 minutes. Okay, he has travelled in 5 minutes. Okay, and the student B was travelling in zigzag with no direction. Okay, speed has no direction. So they are dispersing, they are travelling in different direction. So let us say student 2 has taken 7 minutes. Okay, student 2 has taken 7 minutes. And student 3, let's say student 3 has taken some like 4 minutes or something. Okay, these are the time noted by these students. Okay, now if I add, okay, all this time, 5 plus 7 plus 4 divided by 3, then I'll get, okay, oh sorry, that would be average of this time. Okay, then I'll get the average of the time. But if I need to calculate the average speed, what I have to do, the formula, total distance covered by time. So you have to note the distance, then you have to divide it by time. Total distance divided by time. Total distance divided by time. So this is how you calculate the average speed. Okay, speed has no direction, that's why students are dispersing in different direction. Now we'll see how to calculate the average velocity. Okay, how to calculate the average velocity. So for this, see, we all know that velocity, okay, or displacement has a particular direction. Displacement has particular direction. Now what you instruct these students, mark the boundaries. Okay, mark the boundaries and ask them to travel in this particular boundary. Okay, in this particular boundary. So this is, they are traveling from initial point to final point. Okay, from initial point to final point in one particular direction. In in one particular direction. Okay, in one particular. So this velocity has direction as well as they have displacement. Okay, this is the displacement, the shortest distance between the points, initial point and final point. So this is nothing but my, what you say, displacement. So similarly, let us consider the student 1 has taken some around 2 minutes. Okay, and student 2 has taken around like 3 minutes, and similarly student 3 has taken around like 2 minutes to reach from initial point over here to the final point over here. Okay, to cover this entire displacement. Okay, cover this entire displacement. So now to calculate the average velocity, we have a formula. The formula is total displacement by time. So let us consider this displacement as 10 meters or like 100 meters. Okay, this is like 100 meters. So 100 meters divided by 2 minutes. 100 meters divided by 2 minutes. We'll get it as 50 meter per minute. 50 meter per minute. Okay, this is in minutes. The time is in minutes, and this distance, this displacement is in meters. So similar fashion, 100 divided by 3. So we'll get it as some answer. We'll get in terms of meter per minute. Okay, meter per minute. So this is how you calculate the average speed and average velocity. Okay, average speed and average velocity. I'll repeat it again. Speed is a scalar quantity. It does not have any direction. No direction. Speed has no direction. Velocity has direction. Okay, velocity has direction. It considers distance, to calculate speed, and it considers displacement. Okay, it considers displacement. Okay, so I hope it is clear.